Alright, so we're moving on to finding area in our geometry unit. And kids, I've noticed this year, easily forget how to find area, so I'm going to try and help them really remember how it works. So here's your warm-up. This is just basic, find the area of the shape. They're already on a grid, so it's not really very difficult. If it's 4 centimeters wide and 3 centimeters tall, then, well, first of all, what is the shape? This is a rectangle. And what is the area? In square centimeters. So that's going to be centimeters squared. Well, this is 1 square centimeter, so it's 3 by 4, which is 3 times 4 is 12. 4, 8, 12. So 12 centimeters squared. This is actually a square because it's 3 by 3. And that would make 9 square centimeters. And this is also a rectangle, like the first one. 5 by 2 is 10 centimeters squared, because it's literally 2 columns of 5. 5 times 2 is 10. So we're going to find the area of triangles, quadrilaterals, and composite shapes and start looking for patterns for finding the area, because next time we're going to move on to actually looking at formulas for area and translating what we talked about today into finding those formulas. The homework that we're going to give out is the summative review packet, which is to help prepare for the summative test, and you can see that we're going to go over the review, have a review in class on the first half of class on Wednesday for periods 5, 6, and 8. Period 1 got really lucky with the schedule, and they get 2 days of review, but Thursday is a shorter day. And period 4 gets Thursday. So the test is going to be open note. You will be allowed to use your notes. And for periods 5, 6, and 8, it's on Wednesday and Thursday. Together, cumulatively, that's like the length of a normal class period, because we'll have the review for the first half on Wednesday. But you do get the advantage of getting to go home in the middle of the test and think about the questions that you saw and study a little bit more to help you prepare a little bit better. Periods 1 and 4 get a really long exam block, but they don't have the advantage of being able to go home in the middle and really think about what they had trouble with. So I think it kind of balances out. Alright, so this is the first section is rectangles and composites, and it's pretty simple. 6 by 5, you count all of the shapes, and it's 5, 10, 15, 20, 25, 30 centimeters squared. And this is 1, 2, 3, 4, 5 centimeters squared. And this is, 9 by 4.5. Well, there's 4, 8, 12, 16, 20, 24, 28, 32, 36, and then half. 2 halves make a whole, so 37, 38, 39, 40 and a half. 40.5 centimeters squared. But most kids remember, or at least will remember once they see this, that you just multiply. 6 times 5 is 30, 5 times 1 is 5, 9 times 4.5 should be 40.5, but let's go ahead and check just to make sure, just for giggles. We'll do 4.5 times 9. Well, 9 times 5 is 45. 9 times 4 is 36, plus 4 is 40. And there's a decimal point, 40.5, that's correct. So multiply. And what do we multiply? Well, we multiply the width by the height. Width by height. Alright. We couldn't do 6 times 6, even though it's 6 across. You have to get the different dimensions. So it's the sides that are different have to be multiplied, not the sides that are the same. Squares are really easy. 4 by 4, 16. 6 by 6. 6 times 6 is 36 centimeters squared. 4.5 by 4.5. Well, you've got 16, and then 1, 2, 3, 4, and a quarter. So 20.25. So just to show you that you can do it by counting, and you can also do it by multiplying. 5 times 5 is 25. 5 times 4 is 20, and 2 is 22. Add a 0. 4 times 5 is 20. 4 times 4 is 16, and 2 is 18. And a 5 and a 2 and a 10 and a 20, or 2 rather. 2 decimal points, 20.25. Okay, so you multiply the side by itself because all the sides are the same. So you just multiply it by itself one time, which actually looks like side squared, 4 squared, you know. This one is 4 squared, which just means 4 times 4. This one is 6 squared, which just means 6 times 6. And this one is 4.5 squared, which just means 4.5 times 4.5. So to find the area without the little grid in there, 5 times 12 is 60. 8 times 8 is 64. And 3.5 times 10. I don't really need to make this problem. I know it's going to be 35, but let's just check. 1 times 5 is 5. 1 times 3 is 3. And there's 1 decimal point, so you get 35. 35 millimeters squared. Then you have composite figures, and I mean, you still have rectangles, it's just they're kind of stacked on top of each other. So you have a 3 by 2 rectangle, or 6, and then a 3 by 7 rectangle, or 21. Then you could count 3, 6, 9, 12, 15, 18, 21. And you put 21 and 20 and 6 together and you get 27 centimeters squared. I can cut this one off here. 7 by 2 is 14. And this is 3 tall and 2 wide. 3 times 2 is 6. 14 and 6 is 20. The hardest part is finding the correct dimensions to use, honestly. I would have had to, if I didn't have the squares in there, I would have had to have said, well, 7 minus 3 is 4, minus 2 is 2, so that has to be what's left over here. Cut this little square off, and it's 2 by 2 is 4. 5.5, I took away 2, so that's 3.5. 1, 2, 3.5 times 4. I'm going to go ahead and do that just with multiplication. That's 20. 12 is 14 with the decimal point, so it's 14. 14 and 4 is 18. And I can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Alright, so if I cut this one across, it'd be 5 by 3 is 15, and 12 by 5 is 60, and together that makes 75 inches squared. If I cut this one, oops, come on. 4 by 1 is 4, and this is, the whole thing is 4, and I have 2 here and 1 here, that makes 3, so that's 1 left over here. So it's a 1 by 2 piece, so it's 2. So the area is 2 plus 4 is 6 feet squared. Alright. This is obviously not drawn to scale because I see 8 meters across and 4 meters for this part. So this part has to be 4 because that's what's left over when I take 4 here and 8 up here, there has to be 4 left here. 4 times 3 is 12. 4 times 5.5. It's 20, 22. And when I put those together, I get 34 meters squared. And that's composite shapes. Now we move on to triangles and quadrilaterals, and it gets a little more complicated. I want the area of each triangle, so just for one triangle. So I see that together these two triangles make a square, and the square is 4 by 4 is 16 square centimeters. But this triangle is exactly half of the square. 1, 2, 3, 4, 5, 6, 7, 8. 8 is half of 16, so it's 8 in each half. So each is 8 centimeters squared. Here we have 24 total, so there'd be 12 for each triangle because 12 is half of 24. Here I have a 3 by 5 triangle. If I counted, it's hard to count because you see these little bits are cut off. I know I have 1, 2, 3, 4 whole pieces, but then I have a bunch of partials. But if I look at these, I can see that I can extend this out, add another triangle exactly the same size on there. 1, 2, 3, 4, 5 wide, 1, 2, 3, 4, 5 wide, 1, 2, 3 tall, 1, 2, 3 tall. So it's the exact same triangle, I just flipped it upside down. And the whole thing makes a rectangle that is 3 by 15. Sorry, 3 by 5, which makes 15. So each triangle would be half of 15. And I know that that's 7.5, but we're going to go ahead and check half of 15. 2 goes into 14 7 times. Add a decimal. 2 goes into 10 5 times, so we get 7.5 because that was exact. So each triangle is 7.5 centimeters squared. I can do the same thing with this one. You can see that it's 3.5, so it's kind of going across at a halfway point, but I can still extend the one triangle. Oh, this is ugly. But the idea being that it's 3.5 tall and 6 wide. There's exactly 2 equal sized triangles, so if I find the area for both and then cut it in half, I have the area for one. So 6 times 3.5. 6 times 5 is 30. 6 times 3 is 18, and 3 is 21. So 21 for the whole thing, and half of 21 is 10.5. I know that because half of 20 would be 10, and half of 1 is 0.5, so put them together, 10.5 plus 10.5 is 21. So that's 10.5 centimeters squared. Alright, this one I can't really just add another triangle. I mean, if I drew 1, 2, 3, 4, 5, 6, 7 wide, especially since this is in the middle, it'd be like 1, 2, 3, 4, 5, 6, 7, and it would go in like this, and it would be a really funky shape. It'd be hard to do. So I'm going to find another method, something else to work with, because this isn't quite working. Let's see. I see that I could neatly cut it in half along this point right here. Get 2 half triangles, right? And what I could do is add on another triangle to this half triangle and another triangle to this half triangle. So this is identical to this, which is identical to this, which is identical to this. So they're all the same thing. So I did kind of make this rectangle. I just did it by cutting it in half first and then flipping the pieces out. So what I end up with is 7 times 7 wide times 3 tall is 21 for the whole thing. But I'd have to split that in 4. Or I could say it's 1, 2, 3.5 by 3. Which, that's 15. 3 times 3 is 9, plus 1 is 10. 10.5 for this whole thing. And I would want half of that, so I'd want 5.25 for each piece. So if I just want the original triangle, it'd be that 10.5. Right? So let's check that with our calculator. Let's check the whole rectangle, 7 wide and 3 tall, which is 21, divided into 4 pieces is 5.25, and we want 2 of those pieces. 10.5, so our area is 10.5 centimeters squared. I could also have done, I cut that in half right in the middle, like this. Here's the original piece, goes out 1, 2, 3. That's the original piece. And then take this piece, which goes half, 1, 2, 3, and then up. So when I cut it in half, instead of adding 2 more, I could have just rearranged it. So it looks like this. And it's 3.5 by 3, which is this up here. This will be easier to see if you could actually physically move the shapes, and we will look at that when I get back. Alright, this one, if I cut it in half along this line, that's the easiest line to cut it straight down. It's not in half, but it's straight down the middle. So I have a triangle that is 1, 2, 3, 4, 5, 6 tall and 1, 2, 3 wide. And then I have another triangle that's 6 tall and 2 wide. So I'm not going to bother redrawing it over there. I'm just going to say 6 tall and 2 wide. Well, here's my 2 wide. 1, 2, 3, 4, 5, 6. There's my 6 tall. And then I have 3 wide. 1, 2, 3, and 6 tall. Okay, so I just duplicated this triangle, but I put this piece this way, and I put this piece this way. So now it's one big rectangle made out of 2 triangles this size. It's 6 centimeters wide and 5 centimeters tall, so it's 30 for the whole triangle. But I only need the original triangle, not the one that I added, and I added a whole extra one, so this is half of that, so it's 15 centimeters. 15 centimeters squared. And let's just count that, because this is getting a little confusing, just to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9 whole pieces, plus, you know, there's most of ones that'd be like 10-ish, 11, 12, 13, 14, then all those little extra pieces, they might add up to about 15. They must, because this is 15 centimeters squared. It's just hard to see it. But you know, this piece here lines up with this piece here. which is this piece. Because this is the same triangle as this one, I just flipped it over. Alright, let's look at another one. If I cut this way. Okay. So if I just flip the whole thing over, it'd be 1, 2, 3, 4 wide. It'd be 1, 2, 3, 4 wide. And 4 tall, so it would go like this. So this is the same triangle, but it doesn't make a rectangle. It's hard to count. So instead of doing it that way, I just flip each piece over. This piece is 1 wide, 4 tall, 1 wide, 4 tall. This piece is 3 wide, 4 tall, 3 wide, 4 tall. So now I have a rectangle that is I have a square that is 4 by 4, or 16. But I only want half of that, the original triangle, so it's 8 centimeters squared. Okay, so those are triangles. We're going to turn that into a pattern that becomes a formula in the next class. Now we have a trapezoid that is 3 by 5. One base is 3, one base is 5, one base is 4. One side is 4. And I didn't do this side because it's not whole square, so it's hard to tell the actual length. But what I do see is that this is the same triangle. 1, 2, 3, 4 tall, 1, 2, 3 wide, 1, 2, 3, 4, 5 wide on the other base. It's just flipped. So put together, they make this big rectangle. It is 1, 2, 3, 4, 5, 6, 7, 8 by 4, or 8 times 4 is 32 centimeters squared for both of them. But I want the area for each. So if the whole thing is 32, then each one has to be 16, because they have to be the same. 16 plus 16 equals 32. 16 centimeters squared. Same idea here. You have a 2 tall triangle with a 2 base, and then a 6. 1, 2, 3, 4, 5, 6 base. 1, 2, 3, 4, 5, 6 base. So it's 2 tall times 6, 7, 8 wide. 2 times 8 is 16, but each is half, so it's 8 centimeters squared. I can do the same thing with this one. I'm going to redraw it. So it is 4 wide, 1, 2, 3, 4, 3 tall, 1, 2, 3. The other base is 2 wide, and I connect them. Then I can do upside down. I can do another trapezoid just like that. 2 wide, 1, 2, 3 tall, and the other base is 4. 1, 2, 3, 4. So the whole rectangle is 4, 5, 6 by 3, or 18. And half of 18 is 9, so each part is 9 centimeters squared. This one I can't really do this with, because if I did, it would just look like this. There's 1 wide, there's 3 wide, and then I connect the side there, and it would make a parallelogram. But I'm not looking for a parallelogram. It's easier to measure if I have rectangles. I could cut it down the middle, but then I'd have half. It'd be like 1.5 here and only half here, and that's confusing. I could also cut it in half this way. So this part is now 1 by 2. So it's 1 wide, not 2, yeah, it is 2. 1 and 2 together, they make 2. So it goes to the half, and then it goes to the half, like So I could also cut it like that, but again, I'm making a parallelogram, so that's not super helpful yet. So, alright, let's go back to the cutting it in half the way that we have done it before method, because that seems like the most surefire way right now. So I cut it exactly in half. So I have something that is half here, 1.5 here, and then I have a partner piece that is half here, one and a half here, and it makes this little rectangle that is one whole, 2 halves, 1, 2, 1, 2, 3, 4, 2 by 4, which is 8 together, or 4 for each piece. But both those pieces came from the same trapezoid, so this side is 4, this side is 4, but together it makes 8. 8 centimeters squared. Or I could also have done that half that I got there. This is half wide. Just like with the triangles, added on 1.5, half wide, and 1.5. So it would have been 1, 2, 3, 4 by 4, which is 16. So 16 for both trapezoids and 8 for just the original trapezoid. Alright, this one, I can cut it down the middle fairly easily. It's not actually 5, this is a mistake. It's 1, 2, 3, 4, 5, 6. Let's change that to 6. Alright, so I can do... I'm gonna do this one with lines. I have 2 pieces of trapezoid now. I have a 2, 1, 2, 3, 2 by 3, 4 tall. So there's my 4 tall, 3 wide, 2 wide, and then connect them. And then if I want to turn it into a rectangle, that's the straight side, so I need to do the short side on the bottom, 2 wide, 4 tall, 3 wide. So I just took each piece and I flipped this one around to fit this one. So this is now a 6 by 4 rectangle. 6 times 4 is 24. And I didn't take away anything from the triangle, I just rearranged it, so that's just 24 centimeters squared. Don't have to do anything else to it. Okay, what about this one? This one's funky looking. What if I cut it like this? So I got a little triangle here. It's 2 wide and 2 tall. And then here I have a trapezoid. Remember, I have to alternate the sides. So the long side is 1, 2, 3, 4, 5, 6, 7. So I'm going to go 1, 2, 3, 4, 5, 6, 7. Down 2, over 1, 2, 3. So here's my new shape. It is now 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 wide and 2 tall. So the whole thing is 24. But I only need the original trapezoid, not the pieces that I rearranged, the duplicate pieces. So half of that would be 12. 12 centimeters squared. have parallelogram. Parallelograms are actually pretty easy. Gonna go ahead and cut it off right here. So this part's easy. It's 4 tall, 1 wide. 4 tall, 1 wide. Now I just need to add this part on, which is 1, 2, 3, 4, 5, 6, 7, 8 wide. 1, 2, 3, 4, 5, 6, 7, 8 wide. And then this has to be the straight side, or else what was the point? And then this corner, which is, and then the top is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. No, okay. So together they make 1 and 8 is 9, 10, 11, 12, 13, 14, 15, 16. Whoa. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yes. No. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Anyway. 4 tall. 64. But I only need half of that. I only need my original parallelogram, which is half of that, so it's 32. Let's see if we can't find an easier way. Because 8 times 4 is 32, so why did I have to do all those extra steps? Well, let's cut it like this. Let's just redraw it this time. So now I have this part, which is 4 tall, 2 wide on the bottom, 3 wide on the top, and then connect it. We have this piece that I took off, which is 1 centimeter wide and 4 centimeters tall. So now I have 1, 2, 3 on the bottom, 1, 2, 3, 4 on the 3 times 4 is 12. Hopefully you're noticing pattern now. 4 times 8, 4 times 3. Let's check the next one. Let's cut it off like this and redraw. 1, 2, 3, 4, 5 tall and 5 wide and 3 tall. 3 tall. 1, 2, 3, 4, 5. And then the other base is 3. Connect them. Then we have a 2 by 3 triangle here to add on to it. 1, 2, 3, 4, 5 by 3 equals 15 centimeters squared. Hopefully you're getting the pattern here. If I cut this off here, scribble it out, move it over here instead, it's 1 wide, 3.5 tall. Now I have a rectangle instead. 6 times 3.5, which is 21. Really? Anyway, that's the idea. This is just a lesson to get acquainted with it, to explore and see different ways to find areas of funky shapes. Next class, we're going to talk more about the patterns that arose and try and actually make some formulas. So I know this was kind of a long one, kind of rambly, but I hope it helped. Keep in mind you have a summative coming up, and please make sure to study. Oh wait, I think I have a picture of that, so let's check that first. Yeah, you got your summative review packet, which starts with the answers to the quiz that we took, so you can see what you did right, what you did wrong, and what you had trouble understanding. And then it has some practice problems.